All right, welcome to section C. We're going to finish up our chapter on volcanoes today. Okay, so we're going to start talking about what's known as intrusive volcanism. So volcanic activity that's under the surface. Okay, what we've been talking about so far is extrusive. It comes out of the surface, okay, and it makes the igneous rock that way. But we can still get all kinds of igneous formations that are just under the surface. And those are the intrusive volcanism. Okay. Again, the extrusive occurs on the top of the Earth's surface, and so intrusive occurs under the surface. Okay. So the magma doesn't just stay in this nice little ball. Okay. All these pictures show this magma chamber in this nice little ball. It's under pressure, and so it's looking for all these different cracks, and it's looking for a way out. Because it's hot, it's less dense, and so it's constantly pushing up as well. Okay. It's trying to get to the surface. So we actually wind up with all these different like little fissures and these little paths of magma looking in all the cracks. Okay, this is the intrusive volcanism, and we name a lot of the formations that are built up as a result of this. Because a lot of times this magma, it will never be able to come out, and so it cools and it stays in place. Okay, so sills are horizontal cracks that fill with magma. Okay, let me get my pen here. Okay, so you can see these are sills. Okay, the magma rises and it finds these horizontal cracks. Okay, but then we've got cracks that are going vertically as well. Those are known as dikes. Okay, so you can kind of not so much this. That could actually be considered like a pipe or a conduit. Okay, but if it's branching off a little bit and going to the side, maybe this little section between the two sills would be considered a dike. And that stuff gets left behind sometimes. If the volcano never erupts, that stuff can cool off and leave some pretty cool landforms, okay? We're going to talk about these coming up, this batholith and these plutons and these laccoliths, okay? So if you want, you can rewind the video to come back and look at this diagram when we talk about those landforms, okay? So intrusive landforms. This is actually known as Devil's Tower. This is in Wyoming. I've been there as well, but I didn't get a very good picture, so that's not my picture. But I've been there. It's pretty cool. Okay, so one of the landforms we get are called plutons, and these form underground when the large magma chambers cool and harden. So these huge chambers of magma, for whatever reason, they're not getting fed with new hot magma, and they're not able to escape. So it just gradually cools off and it forms a solid formation. That's a pluton. Okay. A batholith is when a very large pluton gets exposed due to erosion. Okay, so if you've ever been to Yosemite and seen, there's this thing called Sentinel Dome there, and then of course Half Dome, which is really famous. That's part of a batholith that was actually exposed when erosion carried a lot of the soil away. And so what's left is basically just this huge section of igneous rock that at one point was a magma chamber. Okay. Smaller ones are called laccoliths. So both a batholith and a laccolith are considered plutons because they form from the magma cooling underground. A batholith is a big one. A laccolith is just a smaller one. Okay. That Devil's Tower over there is known as a basalt column. I'm going to share this PowerPoint with you because that's actually a link to how these are formed. There are some funky formations. This basalt, as it's cooling, it actually forms very consistent patterns. It makes these like hexagonal shapes. And so all those little vertical tube kind of looking things just form together as the magma is cooling. And like I said, they make some really, really interesting landforms. So I would highly recommend you looking more into that, okay? We also get a lot of hydrothermal features from this volcanic activity, okay? So hydrothermal, let's break that down. Hydro means water and thermal means heat. So basically this is water that's being heated because it's close to a volcano. So you might have a magma chamber surrounded by rock, and then you might have an aquifer, which is a collection of groundwater, close to that. And so that water is being heated because of the heat being transferred through the ground from the magma. And that causes some funky things, kind of some cool things, okay? So we might have hot springs, natural hot springs. If you go to Mammoth, there's a lot of natural hot springs that you can actually get into. Some of them are pretty hot. Some of them are too hot. You can't get into them, but a lot of them you can. And this is basically a natural spring of water. It's a natural collection of water that's being heated by that underground activity. Okay. Now the hot water it can dissolve a lot more minerals than cold water. And so we get some different like mineral deposits from this water. The water itself can actually have a lot of therapeutic value to it. The minerals can be very good for you, for your health by getting into it. Okay. But the minerals can leave these formations behind. If you look on page 195, you get these things called terraces, which is it looks kind of like salt crystals, but it's basically the minerals being left behind from these natural hot springs. You can also have what's known as a mud pot, and that's when the spring has been filled with volcanic ash, but it's still hot, and so it looks like this bubbling pot of mud, and it might splatter mud everywhere. Okay, it's known as a mud pot. Then we get geysers. Okay, that is Old Faithful in Wyoming. I'm hoping to go there this summer and get my own picture. A geyser is basically a hot spring from underground that the heat is increasing the pressure. Do you guys have like an old school teapot at home with like a little cap on it, and when it starts boiling, it whistles? Okay. Well, what happens is when you're heating the water, its pressure is increasing and it's putting out steam. And so the steam goes through that little cap and it makes it whistle. Okay. In a geyser, the water is heating and it's expanding and there's a lot of steam. And so it's building up all this pressure. Well, eventually that pressure needs to escape. It just kind of pops its cork. And so a geyser is kind of a popping of the cork of the underground water at a fairly regular interval. Okay. There's lots of geysers all around, but Old Faithful is probably the most famous of them. We can use geothermal energy. So geothermal would be earth, thermal is heat. So this is heat from underground. For a lot of things, the hot springs are kind of a cool recreational thing. But we can actually use that energy to heat homes and provide electricity. Okay. Geothermal energy is, like I said, energy from the heat that's produced by the magma underground. Okay. So that hot water produces steam, which can then be used, like the old steam engine trains, they burned coal to heat water to produce steam because the steam could turn these mechanical things to actually move the train. Okay. So you can use steam to turn like these turbines that can produce actual electricity. Or you can actually pipe the hot water into the home to actually heat the home or just use for hot water. Recreational uses, hot springs are really fun to be in. Feel good. It's like a natural spa. And then, like I said earlier, the health benefits of the minerals themselves. This is actually a picture of a hot spring in Iceland. Iceland produces 85% of all of their electricity from geothermal energy. Okay. And then the hot spring that's seen there has a lot of, I can't remember what kind of mineral it is, but it actually has really good health benefits for people that suffer from psoriasis, which is a skin kind of disease, I guess, a skin, I don't know, I can't think of the word I'm trying to say, irritation, I guess. But the minerals that are in that hot spring really improve the psoriasis and help take it away from some people. So anyway, fun fact. So the US actually uses more geothermal energy than any other country, but we have so many people in our country that it only accounts for like, what did it say, 2%? Less than, yeah, about 2% of our energy is generated by geothermal energy. Iceland doesn't produce as much energy as us, but since they have less people, it's actually enough to cover like 85% of their need for electricity. Pretty crazy. That's it. That's the end of the chapter. See you guys later.